Hello everyone, it's January 15th. My fingers are cold. It will affect my typing. Bitwise exclusive of all pairs. You're given two zero-indexed arrays, non-negative integers. There exists another array, nums3, which contains the bitwise exclusive OR of all pairings of integers between num1 and num2. Every integer num1 is paired with every integer num2 exactly once. Return the bitwise exclusive OR of all integers in num3. Okay. So we have num1. Man, it's not only typing, I'm also writing slowly. What is this? 0, 1? No, that's not 0, 1, man. That's 1, 0. This is 0, 1. This is 1, 1, right? Okay, nums 2. 10. What's 10? 10 is 8 plus 2. So I think this is 10. 2. 5. 5 is this. And 0. Okay, so we'll exclusive of everything with everybody else. Everything with everybody else. And then for this, it's going to be 3 times 4, right? 12 pairs. So this, and then we'll exclusive of everybody again. So basically, what we have in this case is, let's call it A, let's call this B. So A0, B0, A0, B1, A0, B2, A0, B3, right? And then A1, B0, A1, B1, A1, B2, A1, B3. Okay, and A2, B0, A2, B1, A2, B2, A2, B3. And then when exclusive of everybody. Okay? So when exclusive of everybody, what you did is we basically exclusive of A0, 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 right? All the A1s exclusive all the A2s, these are all 0. And then B basically will become B0, exclusive all B1, exclusive all B2, exclusive all B3. Right? And we can imagine if we have odd count of A, oh no, not odd count of A, odd count of B, then we'll have a A0, B4. Right, A1, B4, and A2, B4. So we're just gonna have to do this exclusive OR as well. So it depends on the count. So if I have even count of this, then it's just gonna be 0. Because everyone will have even count, so it'll be 0. If it's odd, then we have to do exclusive OR of everything. And it's the same. Okay, so I think we have the solution for this. Not really difficult. So basically we say if nums1 dot size mod 2 equal to 1, then we can say int res equal to 0, right? Then what we need to do is go through everything in num2 for n, for int n of num2. We say res exclusive OR equal to n, right? And then we say if nums2 dot size mod 2 is equal to 1. Oh, Then for int n in nums1, we say res exclusive OR n, and then we'll return res. Okay. Alright, give us a shot. I'll run it. And what we're gonna do here is, oh, I think my hand temperature is rising. 2425. Write out all the pairs. We will see that for each number in nums1, it will be exclusive OR to itself, len nums 2 times. This means if len nums 2 is even, all the exclusive OR of each number in nums1 become 0. Otherwise, we have each number in nums1 exclusive OR each other exclusive. Now we have total exclusive OR of every number in nums1. Same applies to nums2. Okay. Submit it. It's very simple. I don't think it requires much discussion. We can go to the tutorial, take a look, size. Huh? Oh, the probably solution 2. Yep, that's about right. All right, let's go back to this problem, which we had it wrong. Let's open this one up. Alright, again, we have a DP solution for this, where dpij is the longest subsequence ending at nums I, right, with absolute difference not smaller than j. So we have 42, 65, 32, and 2, right? So dp will be high minus low. So it'll be 63, right? So we have 63. Actually, I think we should just test this. Yeah, let's just test this. What's the result? Expected 3. Okay, let's put it here. All right, so last indice. Okay, let's do this. So I is 1, then on 63, then OP1. What did you do? I pressed F3. Shoot. Go again. F1. Okay. We have pre 128. That's too much. Okay. And here pre is pre is 2, but we don't have 2. Right? We don't. Oh, we have 2. Huh? Oh yeah. 65. We do have 2. But 2 we haven't handled it yet. Okay, so we look into the left. So that should also be false. Okay. So both are not good, and dpi j plus 1. So dpi j, hold a second, where is dpi j? dpi 1, j plus 1, but we don't have j plus 1 because j is too big, which means now res equal to 0. Yep, that means we start at position 1, which is 65, and we say if we want a the difference, absolute difference, to be 63, and then we don't have any. Ooh, we don't have any. Shouldn't that be? Shouldn't that be 1 instead of 0? Because in that case, let's keep going. And then we have 62. Oh Lord. 63, 60. Oh, we're gonna keep going, all right? So up until 33. No, 13. Oh, 23. 23. So we have to go to 23. Oh my god, that's gonna take a while. Yeah, I'll have to go to 23. Okay. Now 23. 23 plus is not gonna work. Minus is gonna work because minus is 42. Right? Because 42 is already in it. Okay. K is equal to last indices. Pre is 42. Last index 42 is 0. So K this should return 2. Right? So OP2 is 2. And dpij will become 2. And the rest will become 2. That is good. And we don't have anything else, so we can just keep moving. Oh, I think this is when we should set another breakpoint. I guess it's fine. Okay, now I equal to 2. Now we're at 32. So 32, the first is 33. Right, but for 33, there should be nothing. So I have to go 33. Okay. Or 33. 33 plus, yes. So 65. And 65 should be good. Yes. And then K should be 1. And 1 with 30 something. Hey, 1 with 30 something. But we're trying to establish, you know what? Yeah, everybody should be 1. Because now this one will return 1. Right? Now this one OP is 1, but OP is not 1. Right? OP should be 2. Which means yes, everybody should be 1. Instead of 0, I think this should be 1. And don't have to and we don't have to do this. Okay. Let's try this. Ugh. That is still not right. I set everybody to 1 already. Huh. Ooh, I think this should be 1. Right? Try again. There we go. That's the one. That is the one. So I'll remove this. Now add a comment. Every number can form a subsequence with itself. Thus the default value for DP is 1. Okay. Let's go. It seemed like we're gonna time out. Dude, why would this time out? It's OMN. There we go. It's not. Oh, holy guacamole. Lord. I've never seen this long before. Let's click it. OMN, exactly. Oh, I can, I don't know. I don't know if it's AI. I don't think it's AI. You don't need AI. You can just hard code it. No, you do need. No, I don't think this is AI. I mean, the time, you can graph it to know what it is. But lordy, 11,240 milliseconds. That's the longest I've ever done. We finished all the Fancy Fest. %. 11240. This is the longest I've ever done, honestly. 11240. And now I'm fully warm. Alright, I think time to read. Yeah, it doesn't have a tutorial. Let's see, solutions. Oh, we only submit once. Really? Oh yeah, I remember, because I randomly put something there and I try to see if it works, and it doesn't work. Yeah, just a little bit things. Okay, DP. Looks like it is DP. Oh, ON solution. Huh. ON. What do you mean you don't have to go through all the J's? Is that what you mean? I mean, technically Technically, you don't, do you? I mean, we're going through every number. But the reason I go through every difference is because I need to fulfill this. No, actually, no. I need to fulfill this. Right? Because I can have a J, which is the difference, right? And then you need binary search and stuff. All right, let's just see. Oh, that looks simple. Wait, they call this ON, but they also need to do this 300, right? They do 300 too. They do this 300 thing as well. So it's n times max value. Okay, this is n times max value. Okay, we've got a diff. Next, diff plus 1. I think this is this thing. But I use the last indices. They didn't use the last indices. Huh. So we go from right to left. That's what I expect. And then for each number, I go, this is the difference. Okay, I understand. And this is dp number and difference. So they basically start from this number. Oh, wait, hold a second. Number difference. That is different. This is number. Huh. Basically, we say starting from this number. Okay, starting from, not the starting from, just, yes, we start from this number, right? And with all this difference, you tell me what's the maximum length that I can get. So to do that, I need to see the next dp next. What in the world is this next? Next is the number, the next number. So basically you're saying, if I start from the current number, and then I see my next number, and the next number has, the next number has 300 different ways. So I just go through all of them. So I go through the next number, and I have my current difference. So the next difference cannot be bigger than me, right? So I have a prefix max, suffix max as well, I think. So I say the next plus 1. That is correct. And I get everybody for that. And I go through the dpnum again to produce the suffix max. And then once I'm done, I go through everybody again and then find it. Oh, so by doing this method, we avoid the use of last indices because we don't have to. Can I upvote this? Yes, I can. All right, let's reproduce this without looking at it. Let's reproduce. So it is the same idea, but easier to reason with, right? Yeah, I won't say easier to reason with, but it's just different. Okay, so I probably need a link. So this solution is inspired by this one. I'll click the link. It uses the same concept, but the meaning of dp is different. Here, dpij equal the longest subsequence length starting from number I, right, with j absolute difference. With j absolute difference. So we're starting from I, say with this absolute difference. But how do we make sure the difference? Oh, yeah, the difference is we can control because the current difference. Huh. And there's no, we just go through all of them. Yeah. For each number, we just go through all of them. The next number can be any one of them. But if the next number, because I have the current difference, so I think there should be another, there should be a check, right? There should be a check. Yes, there is a difference. There's a difference because the difference cannot be bigger than this, right? So we pick what the next number should be. Now we have a difference, right? And then we use the same difference. Yes. Yeah. So we start from any number, right? For the current number, we can pick, we go through all possible next numbers, right? And for each next number, we have a difference. We have an absolute difference, right? Then to find the max subsequence length of the next number, we use dp next and diff. So dp is gonna be same thing. Actually it's gonna be 300. Ooh, 301. Okay, then we need to go from right to left and remember to set each dpi to be a suffix max. So for I, awesome, range line nums -1 -1 -1. Alright, we can say n equals nums I. And then for j, not j, for nn in range from 1 to 300, because that's what it is. Diff shall is abc, abc, abs, n minus nn, right? Because this is my next one, and this is the difference. Then dpi, no, dpn nn should equal to maximum dp n nn Do we even need, we do need n dp next with diff. Actually, no, this is not n. This is diff. With the diff equals this diff, right? The current one, the diff, the next number with diff, and then plus 1. And once we're done, we say for for j in range len dpi. Actually, suffix max. No, prefix max is not suffix max. Yeah, to be prefix max. Because it's smaller, right? So it's smaller. So we say 1 to this. We say dpi. Why you constantly say dpi? It's dpn. J shall equal to maximum dpn j dpn j minus 1. So we'll do this, that way return maximum max row for row in dp. I wonder. Maybe it'll work. Let's give it a shot. M. Well, what is your n here? That's the same. That's also n is also the maximum. Okay, let's give this a shot. You have attempted to run code too soon. Please try it again in a few seconds or subscribe to reduce wait time. I wonder how much reduction in wait time it actually is. Okay, now the question is, how fast do you think it's gonna get? This one is slow. I mean, DP is bigger, right? It definitely is bigger. And we have 2 function calls, which is not that bad. And we have an extra array. Interesting. Let's see. Because the time complexity is the same. Yeah, I think it's about the same. 9684. It's actually not the same. 9684 milliseconds and 58.56%. Yeah, it is better. Surely better. Surely. All right, this one is done. Good. Wait, move on. I think it's press this button. Nope. We can read through the problem and see if there's any ideas. Maximize subarray sum after removing all occurrences of one element. So I have nums. You can do the following operation on the array at most once. Remove any integer x such that nums remains non-empty, or on removing all occurrences x. Choose any integer x such that nums remains non-empty on removing all occurrences of x. And what if everybody in it is exactly the same? What you gonna do? Yeah, this is gonna be Python if I really want to try it. Hold on, let me just try it. Let's say we have 1, 1, 1, 1. Oh, then you don't remove, right? Then you don't remove. Yeah, yep. You just don't remove. Remove all occurrences of x from the array. Return the maximum subarray sum across all possible resulting arrays. Huh. Okay. The original one, yes, and then we can remove -3. Remove -2, remove -1, and remove 3. Maximum subarray sum is, I remember it's Cardane, right? I remember it's Cardane. So basically, oh wow, we only have 2 people online now, 25. Oh no, studying this problem currently. I thought it's a total number. I was like, if LeetCode only have 25 people online at the moment, that the company's not gonna survive. No, it's the number of people on this problem. Earlier was 2, and I was even more worried. 25 is a different problem. And you know what? I'm interested. So how many people are in today's challenge at the moment? 6,079. That's good. I wonder how many of those are paying customers. I mean, I am not a paying customer. You have any thoughts on this? So remind me what Cardane does. What is Cardane? Oh yeah, and it's also related to positive and negative, right? If your value is all positive, you basically don't remove anything. You pick anything, just don't remove. And it's only when it's negative that you have to deal with, right? I think Cardane is you find the subarray ending at the current one, what's the maximum value, and then when you start a new one, you ask the question, will it be better if I start myself? Because you don't have 2 choices. One is you start yourself, the other is you add to the one in front of you. So you pick the bigger of the 2, right? You pick the bigger of the 2, and then you go through. It requires ON. Cardane is ON to compute, and you have so many options. You can't just remove one, create a new array, and then Cardane it, right? Although that is brute force, right? That is brute force. What we do need is to analyze. When you remove, I think we can all agree that we do not remove the positive numbers, because if you remove the positive numbers, you just give yourself a hard time. You're not gonna get any better. So we need to remove negative numbers, right? We need to remove negative numbers. And the question is which negative numbers to remove. And we can have duplicates, right, of negative numbers. We might want to think about, yeah, that's the thing. If you go through the current and you find the subarray sum, the maximum, that might not be right, because you can have a very giant negative number jammed in between, right, some positive values, and bring down the subarray sum. But then once you remove it, the whole thing becomes super big. Yeah, this is also possible. This is also possible. All right, we might need some, I don't know. I have no clue at the moment. What feels to me is we need some prefix sum so we can compute subarray sum faster. So let's say we have prefix sum, okay? And then we say, so basically the ideal is if I remove a number, right? If I remove a number, how do I find you may say, we'll remove a number such that the total sum is the biggest. Like in the first example, if you remove my minus 3, that's negative 3, right? That's the total impact. But if you remove minus 2, the total impact is negative 4. But of course that's not the case, not always the case. I can definitely imagine how this is going to work out. Yeah, that's not going to be the solution, just providing some insights into this. Yeah, if you remove some number, and that means you would change some subarrays, right? You would change some subarrays. Oh, dear me. Alright, so if you have negatives, and when you do prefix sum, not prefix sum, when you do Cardane, right? When you do Cardane, you essentially avoid negatives. Unless everybody is negative. If everybody is negative, geez, if everybody is negative, what do you do? Oh wow. If everybody is negative, then I mean, it's the same, right? It's the same Cardane. You just oh, hold on. If everybody is negative, then your answer shall be, I was going to say your answer. If everybody is negative, then the maximum subarray sum is going to be the biggest, the smallest negative value, which means, why can't you test this? So basically, if you go 1, minus 1, minus 2, minus 3, minus 4, the answer shall be minus 1. So this is still a trivial case, right? Yeah, this is still a trivial case, okay? So now we only need to consider a mixture. So I have a mixture of positive and negative, right? If I have a mixture of positive and negative, then the maximum subarray sum is going to be islands, right? It's going to be islands of positives. So we can definitely identify, right, the maximum subarray sum. Yeah, it's just gonna be an island of positive values, and then we have some negatives, and I have another island of positive values. But then, wait, hold a second. And what is maximum subarray sum? What is Cardane again? Oh, wait, hold a second. Yeah, it's you remove yeah. So it's not just the island. You can put things together. Yeah, you can, like, let's say a -1, right? So you put it in. You always put it in, and then the current one, yeah. You can have negatives. So it's not just islands, but you can start with islands, right? You can start. So I have these islands, and they're separated by the negatives. And you say I want to remove the negatives. So you will say, okay, so it's like, I don't know. So all the positives, we can form a group, right? So we have some negative, and then we have positive, some negative, positive, right? Negative. And my current thought process is we'll combine these together. So basically we have a negative, and a giant positive, negative, giant positive, negative. Okay? That's kind of the current idea. And when you remove, you're basically changing, you're changing the, it looks like a node, right? And this is like an edge, and you're saying we remove some edge, and then we're trying to see if we can make it better. Well, so right now I think the number of positives will be limited because we are grouping them together. So in this case, yeah, it's actually already grouped, right? So we have a -3, and we have a +2, and we have -2, -1, and we have a +3, and we have -2, and then we have +3, right? So this is kind of how to distribute. Now the ideal, or the maximum that we want, is if we can remove like all of this and all of this, so we can connect them together. But we cannot, and also because we can only remove one x, right? One value. We can do at most once. So in this case, we can prioritize the ones that with only one number in between, because we know if we remove this number, we can definitely get them together, right? We can definitely get them together. And then we can run the Cardane in the remaining. Yeah, that's how it would do. So now the situation is we have some edges with multiple negative values. Some edges has maybe 1, right? And it's guaranteed. It's not guaranteed. We can trial and error. And just say, or is it always better to remove? I think we can, right? Can we say that it's always better if we can merge two positives together? It's always better than not to merge them. I don't know. I doubt it. Now we definitely can just say remove the most negative one, because in this case, if we remove -3, it basically has no impact, right? It basically has no impact. Anything to the left or to the right of the last and the first positives has no impact on the subarray sum. We need to remove the negatives in between the positives, right? In between the positives. And if we remove the negatives that directly connecting two positive islands, and this has a direct impact because we basically create a bigger positive. But I'm trying to think, right? If this is the optimum strategy, so would it be a scenario where, yes, I can definitely see a scenario where we remove some negative that doesn't really connect the positives, but because that negative is like, for sure, if we have this -200, right? If it's -200, and then the best will be to remove this -200, right? And then we have 5, right? The result will be 5. Well, actually, no. Oh, actually, yes, right? The result will be 5. Because if I remove -2, there'll be 6, there'll be 5 as well, right? There'll be 5 as well. Trying to think, maybe it can be like a cost type of thing, but it's not really a graph, right? It's just in one line. Maybe we can do DP. How do you want to do DP? Well, the thing is, when you remove 1, you remove all occurrences of this one. So it will have multiple impact. So maybe we can compute the negative. What's the negative? Total negative here. Total negative. So for each stretch of a negative, you can also compute its value, right? I mean, the whole purpose of this is to... what's the whole purpose of this? Because I want to know, once a negative is removed, how does it change overall, right? Yeah, because some of them don't change, some of them do change. Huh. No clue. No clue at the moment. I guess we have to table this a little bit. Maybe I'll think about it. And we'll come back to this. Good problem. Good problem. All right, that'll be it for today. I'll see you guys tomorrow. Adios.